Hello and welcome to IoT Builders. This is a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, all from an IoT Builder perspective. It is April 12th, and this is episode 24 of our weekly live stream. My name is Dan Gross, and I'm a senior developer advocate at AWS, focused on IoT and FreeRTOS. I am joined today by my colleague and co-host, Nenad. Hey, Nenad.
Hey, hi everybody. I'm Nenad. I'm a senior developer advocate for AWS IoT as well as UDAN, same team. But my specialization would be around Greengrass and Edge, that kind of stuff.
Well, welcome to the live stream. And we've got some great topics to discuss today. So we're going to talk about LoRa and geolocation and asset tracking and uh, possibly a lot more.
Yeah, I'm super excited about this topic.
So joining us today to talk about some of these topics is Pedro Mendoza from Semtech. So let's bring him on. Hey, Pedro.
Hey Dan, and thanks a lot, both you and Nenad, for hosting me here.
Absolutely, absolutely. So thanks for joining. Really excited to talk about LoRa in the context of IoT today. How about a little intro from you, and maybe a little bit about your role at Semtech, and maybe a little bit about the company.
Yeah, absolutely. Yeah, so my name is Pedro Mendoza. I'm a solutions architect within Semtech, working from Madrid in Spain. And I'm part of the IoT connectivity and cloud service within Semtech. Semtech as a company, like say, includes several business units ranging from signal integrity to power protection. But in the space I'm mainly working in is about connectivity. So we have, like say, a history in the LoRa and LoRaWAN space. And more recently, we have closed the acquisition of Sierra Wireless, which is a cellular technology company, including a virtual mobile operator. So now we are really excited about the intersection of these two worlds, right? LoRa and LoRaWAN and the cellular technologies.
Yeah, so it's all about the radios, I guess.
That's correct.
Yeah, this is one of the things we talked about a lot on this podcast. Is kind of this infrastructure, which is really important for the IoT. So yeah, looking forward to this discussion.
Yeah, so let's jump into it. So let's talk a little bit about LoRa and what that technology is. There's some different terminology, right? LoRa, LoRaWAN, LoRa Edge, some of these terms. Um, Maybe tell us a little bit about maybe some of the differences or what those technologies mean.
Yeah, absolutely. Yeah, LoRa stands for long range and is basically a communication technology that enable users to deploy devices that will communicate over long distance, right? With two main characteristics. This will be very low power consuming devices, which is, let's say, ideal for use cases where you are deploying those devices in hard to access location and you want devices to, let's say, run and transmit data for long periods of time, right? Typically are battery operated devices. And these devices will also, let's say, be characterized by the fact that they serve use cases where you don't really need to send, big amounts of information, right? But rather typically small payloads, and you don't need to send them, let's say, in real time, right? So some latency needs to be allowed on those use cases, right? That basically
Hmm.
implies that LoRa is especially, let's say, popular in use cases such as smart metering, like water metering, gas metering, but also in other verticals such as smart agriculture for doing, let's say, soil moisture sensing or cattle tracking in the tracking space that we will be discussing in more detail, right? And also there are industrial use cases that certainly can benefit from LoRa as a communication technology.
Yeah,
Yeah.
fantastic.
I remember this when we were evaluating this back in the days. It's like it also I mean, there is a reduced consumption of energy, like since you have smaller amounts of packages and all that stuff. So that's also one of the benefits I've seen. I don't know, is that something that customers are also looking for, right?
Yeah, absolutely. I mean, I think probably we have some pictures then that might help to
Cool.
kind of position LoRa compared to
Excellent.
other wireless technologies, right? So yes, as we can see in the picture, right, the
Nice.
sweet spot for LoRa is, as mentioned before, ranges that can really, obviously depending on the obstacle that you will find in the transmission line, right, but can in the outdoor can really range to let's say several kilometers, right, with a very low power consumption, right. So
Mm,
compared to Wi-Fi or BLE, you can get much higher bandwidth, right, but certainly it will be constrained in terms of the range that you can get, right. And then finally, other wireless technologies such as cellular can get, let's say, similar ranges as LoRa, but with a significant power consumption, right. So let's say depending on the use case, you will need to go one way or the other, right. But no, you're completely right. So these use cases that kind of benefit from the low power consumption and hence the ability to have a long life using battery operated devices, and can accommodate the data transmission needs to be, let's say, those with low frequency, minutes, hours, even days, and small payloads are the perfect use case for LoRa as a communication technology.
mm. And by low power, I mean, this is, actually kind of significantly low power. It doesn't necessarily show that on the graph here, but maybe as a ballpark, what are you seeing as maybe the difference in these power consumption
Yeah,
profiles?
to put a let's say easy to understand numbers, as and I will be discussing about this in the, let's say, later section of the session today, right? But we have found that trackers that operate with the newest technology coming from Semtech, what we call LoRa Edge, can really double or even triple what will it take to other devices that use traditional GNSS approach for capturing data and sending data, for example, over cellular network, right? So you can expect this level of, let's say, battery lifetime increase by relying on LoRa as a communication technology, and also, as we will be discussing later, on the architecture of LoRa Edge in order to power asset tracking solutions.
Cool. Cool. And so, maybe now would be a good time too to go into, what do we mean when we talk about LoRaWAN, for example?
Yeah,
So LoRa
absolutely.
is the radio, technology essentially, and oh, you've got that here, LoRa
Yeah.
versus LoRaWAN. Perfect.
Yeah, correct. It's a very kind of common question as well. I mean, both terms sometimes even are used interchangeable, right? And there is a clear boundary, right? So LoRa, as a, let's say, modulation technology, deals more with the physical layer, right? And as you can see, basically covers obviously the modulation algorithm itself, right? And also the definition of which are the frequency bands that are allowed in each of the regions where LoRa is available, right? It's important to mention, and that's another, let's say, interesting characteristic, and I will say advantage of LoRa over other wireless communication technologies, the fact that it operates on what is called unlicensed spectrum, right? So
Mm,
that basically means that if you want to deploy your LoRa network to serve your, let's say, smart agriculture solution, you don't need to really apply for costly or hard to obtain license, right? But instead, it uses this what is called ISM band, right? That are, let's say, devoted to be directly operated by users, right? As far as they observe the certain regulation. It's not like there are not regulations. There are, I would say, strict regulations that you must observe in terms of how much time your devices will be transmitting, information, but that regulations are typically enough for those use cases that we described. And this is what LoRa covers. Semtech, as a silicon manufacturer, is basically the company producing the chips, the integrated circuits that will power every LoRa device, right? Basically, we produce transceivers that will be embedded in, let's say, devices such as a motion detection sensor
Mm.
or temperature and humidity, right? And we will be showing all the devices later today. But that's where LoRa ends, right? And then on top of it, LoRa Alliance, which is a open organization with hundreds of members, including Semtech and AWS as well, they define how LoRaWAN as a protocol is structured, right? So it includes the different types of devices that are mainly have implications on what is the let's say reception window, or how the reception window on these devices is defined, and also the actual MAC commands that these devices can handle, right? And then
Hmm.
finally, on top of it, you have the application layer, and that's where you will, let's say, have your, I don't know, predictive maintenance solution to early detect a failure on a LoRa connected devices, or your asset tracking solution, right? This is the domain of the application itself, right? Somehow connected to that, the, let's say, topology of a LoRaWAN network looks like this, right? So
Mm.
as you can see, everything starts with the devices. I show a couple of them, but if you are more of a, let's say, a kind of dev kit oriented person, you can also have something like this, right? This is
Hmm.
an Arduino board with a LoRa shield, right? And basically you can write your application and control everything using this type of device. Then you have a LoRaWAN gateway, which is just some sort of, let's say, backward forwarder, right? So these two pieces will talk using the LoRa physical layer, right? And then from this point, the gateway will move into the IP space and will, for example, use the LNS protocol to connect to the next component in the topology, which is the network server. Network server is responsible for several things, such as, for example, the duplicating, because as you can see in the diagram, the same device can reach the LNS over different paths, over multiple gateways, right? That also enables some level of redundancy, right? And finally, the network server, let's say, push the information to the application server where the actual solution is implemented.
Hmm.
Yeah.
And what's really cool about LoRa WAN here too is the distance between the devices or the end nodes, and line of sight to the gateway
Yeah.
is can be quite long,
Yeah. Yeah.
miles even.
Yeah, that's correct. I mean, it can get quite sophisticated as well. So there is a concept called a spreading factor, which is a
Mm.
way that can also be automatically controlled from the network server based on the let's say signal strength information that it's observed from certain nodes, right? And it allows to somehow control, let's say, on one hand, how much data. I mean, what is the maximum payload size, right? And on the other hand, the distance, right? So if you have a device
Mm.
that is pretty close to a gateway, right, then you can adjust the spreading factor to use a spreading factor that will basically reduce the required power and enable you to transmit larger payloads. But then as you get farther away from any gateway, you can again adjust this spreading factor, right? But you're right. I mean, it heavily depends obviously on the obstacles that you will find, right? But yeah, the link budget, the maximum link budget can be really high,
Mm.
right? So we're talking about, as you mentioned, kilometers in the rural space. It is, like say, common to have deployments that enables sensors to reach gateways within a distance within the range of tens of kilometers. I would say, yeah.
Wow.
Mm.
Yeah. Fantastic.
That's pretty cool, but it also depends on the frequency, right? I think there was this. There's a lower frequency as well. I mean, that's. I guess you reduce the bandwidth, but then you increase the distance, right?
Yeah, exactly. Splitting factor take care of this
I see.
let's say
Got it.
balance, right, between distance
Mhm.
coming from the transmission power and the amount of data. It obviously also have implications on the those restrictions that I mentioned before, right? So the time on
Mhm.
air is something that you need to take into account in order to make sure that you are, let's say, compliant with these regulations
Yeah.
any given time. This is screening factor, also known as data rate, I guess, in the US lingo, right?
Yeah, very cool.
And important to mention as well, then and Nena, that obviously all this communication happens over a secure channel. So LoRaWAN uses AES, Advanced Encryption Standard. And it's also important the fact that it's, let's say, encrypted at two different levels. So on one hand, the link between the end device and the network server uses an encryption layer. But then, as you might have a solution, let's say, running on a different environment or a different provider than the network server, you have a second layer of security between the device, the end device, and the application server, right? And that's very very cool, right? It's really,
Yeah.
I mean, provides strong encryption, strong encryption, which is a must, as you know. Yeah.
Yeah, that's pretty cool.
So I think we'll get into this later, but as far as a network server goes, there's a service on AWS that will work for this, right?
Yeah, absolutely. Yeah, yeah. We can go a bit deeper, but yeah, it's I mean, AWS IoT Core for One is a managed LNS, right? Which is I mean, as with any managed service, a really good option if you want to deploy your private network. I mean, networks can be both public examples. Being, let's say, typically national operated networks such as Swisscom or Orange in Europe, right? Also Senet or EveryNet in the US. There are many others, obviously, but you can also need to deploy your own network. For example, if you are deploying on a region which is not served by any of the public providers, or if for some reason, for example, security, you might want to you want to make sure that no one else is using your network infrastructure, right? And for those use cases, using AWS IoT Core for One, or AICL as we keep it for short, it's a really a good choice, right? Also because it will, as we will see later in the session today, it will simplify the integration from those end devices into the rich AWS ecosystem
Mm.
service.
Great, great. Okay, where should we go next? I think I'm excited to learn a little bit more about the actual technologies, maybe the chipset, that kind of thing.
Yeah, absolutely. Yeah, let's get a bit deeper then, Nenad, on the let's say the problem we are trying to solve. I mean, obviously, LoRa and LoRaWAN are the
Mm,
underlying technologies, but we are focusing today on the let's say use case of asset tracking, right? And asset
mm,
tracking, what we found is that is a very popular use case. You can find it basically across all the different verticals, right? Ranging from smart agriculture, when you want to track your cattle, understand what is your, let's say, your cows at any given time, understand how you can use the location together with the some health parameters to get a better insights on your cattle, right? But also in the industrial space. I mean, for example, if you want to be able to quickly locate a high value instrument in a factory, uh, certainly in the healthcare or small business space. I mean, it's basically quite pervasive use case, right? And based on that, we at Centec tried to understand if there was any innovation that could somehow help our customers, right? By targeting specific use cases within asset tracking, right? So
hmm
the challenge we found were mainly about power consumption. So if you have, let's imagine that you have a large fleet of trackers. For example, this is a sample tracker, right? For, let's say, I don't know, a fleet of containers, right? So these trackers will be located in a hard to access position. So replacing batteries every 6 months will
Mm.
quickly get the total cost of ownership of this solution to a hard to maintain point, right? So what we tried to do was basically rethink the whole process of a traditional or also called on-chip GNSS solution by let's say splitting the compute intensive location computation away from the chip, away from the device, and into a cloud component, right? And
mm,
that's where SEMTE basically moved beyond the traditional LoRa transceiver space and start producing what we call the LoRa Edge family of chips, which are basically chips that, in addition to best-in-class LoRa transceiver, also includes two scanning components. The first is a GNSS scan, right, which is kind of a generalization of what we typically know as GPS, right? So we
Mm.
support GPS as well as other constellations, such as Beidou in China, for example.
Mm.
The GNSS scan, and we will dive a bit deeper next, right? But will help you to track your asset when you are in outdoor conditions. For example, you have clear view sky, right? But then sometimes you also need to do indoor tracking. So, for example, when you are inside a warehouse or when you are inside a factory, right, you will not have the ability to really receive GNSS signals from the satellite, from the space vehicles. So you need an alternative, and that's where the Wi-Fi scanning feature of the LoRa chips comes into play.
This is cool. So this LR1110 actually is kind of two radios or transceivers in one, which is really great. It's both a LoRa radio, but it's also this GNSS scanner, along with Wi-Fi too. So
Yeah, that's correct. Actually, three
yeah,
three radios, so to say.
all in the same package. And so
Yeah,
that is pretty neat. This is like, tailor made for asset tracking,
Nice.
right?
yeah.
Nice. And what I'm always wondering, like, what is the precision there? So, I mean, when you're in the open field with GPS or generally GNSS, you get this meter range, but like once you have requirements to go below that, like, is that possible with this?
Yeah, that's actually an excellent question, Leonard. I mean, typically we let's say position the LoRa Edge family of chips, and to be strict, is not just LR1110 but also LR1120 that also has
Mhm.
support for 2.4 gigahertz, right, which is quite
Yeah.
interesting space as well when it comes to LoRa. Um, these two chips basically, especially on GNSS, we have observed accuracies in the order of, let's say, 10, 15 meters, right? Which is good enough for most of the use cases, right? But as you rightly point, if you need to go, let's say, below that value, then probably you are better served with a traditional discrete on-chip GNSS solution, right? That's basically coming from the fact that, as I mentioned before, instead of doing the computation locally on the chip and obviously consuming a
Mhm.
higher amount of power,
Yeah.
the way the LoRa chips work is that this GNSS scan will capture the minimum amount of information from the space vehicle
Makes
and then
sense.
transmit it over LoRa. I mean, typically over LoRa, but you can, I mean, you are not constrained, so to say, or you are not forced to use the LoRa transceiver, right? You can use the LoRa chip just for the scanning, GNSS and Wi-Fi scanning piece, and then rely on an alternative communication
Mhm.
mechanism, right? But let's say the natural way to use it will be use the LoRa value, right? And a third component that is on the picture, but we haven't mentioned, and it's quite important, is that in addition to the Wi-Fi and GNSS scanner and the LoRa transceiver, LoRa chips also include a hardware crypto engine to speed up the actual crypto operations required to secure the channel,
Mm.
and a secure key store. So as we mentioned before,
Nice.
these session keys based on IAS are derived from a root key that in this case is contained in the chip, right? Which is, as you perfectly know, right, in the IoT space is one of the main challenge. How do you securely claim and provision a device, right? So this is
Yes.
something that LoRa comes, let's say, out of the box, right? So yeah, it's very, I would say, it's very innovative, right? The approach of, let's say, using or let's say splitting or sharing the complexity between the chip and then a cloud solver, right? So this raw message, what we call a nav message, is transmitted from the chip or from the device to a cloud component. And then on the cloud, where you are no longer constrained in terms of power consumption, you can produce the latitude and longitude that can be used downstream, as we will see later today in your solution, right? But the general idea is that we push the power consumption part to the cloud. And as
Mm.
mentioned, I mean, the business benefit is that you are for this large fleet of devices in hard to access location, you are moving from 6 months battery replacement cycles into 2, 3, 4, 5 years, right? Which is again,
Mm,
when you
Very cool.
handle at a scale, it can be a significant improvement.
that's fantastic. Yeah. Is that so? Do you have more slides here, or
Yeah, I
yeah?
think we have few more. So let me try to
Okay.
quickly. I mean, this is
Ah,
a
yeah.
more dive deep picture of how things were, right? Basically, I mean, everything starts obviously with the space vehicles, right? That are always transmitting information to the LoRa chip, right? And
Hmm.
then the LoRa chip will package and send this nav message to the cloud component. It will follow the you know previously discussed LoRaWAN topology. So it will hit the network server through a gateway. It will then be forwarded to some sort of application server or middleware. And then finally, this is the component that invoke the solver, right? And on the solver, we rely on more precise information about the space vehicle, what is called ephemeris, right? To actually compute
Mhm.
latitude, longitude, and altitude as well, right? We also produce some level of, I mean, some information about the level of accuracy that has been that can be guaranteed for that measurement, right? And what is also quite interesting is that in addition to the, let's say, more basic autonomous GNSS operation, uh, LoRa chips also support what is called assisted GNSS, which is an augmentation of GNSS that allows you to further reduce the scan time in the device by having some rough information of where the space vehicles are located and where the actual device is located. These are
Mm,
called as aiding components, right? So in order to push this aiding component, which is a rough position and an almanac that contains information about where these space vehicles are at any given point in time, you need to leverage a bidirectional communications channel, right? And this is
Mm.
achieved in this case using the LoRaWAN downlink channel, right? So I mean, it's quite interesting from the technical perspective, right? It's very obviously it imposes certain technical challenge and so on, but I mean, ultimately the benefits is that especially using assisted GNSS, you can really have long battery life by leveraging all these
yeah.
mechanisms.
So this nav message is essentially kind of a raw message that needs computation to really
Absolutely, absolutely.
expand out, and
Yeah,
so you're
yeah,
offloading that computation into the
to the cloud.
cloud,
Yeah,
and really saving the battery life. That's
yeah.
yeah, very very clever.
That's precisely, yeah. That's I agree. I mean, it's quite. I found it also quite innovative, right? And then just again, stepping back a bit on the business value, right? This is an example of how in addition to the battery consumption reduction, right? You also benefit using LoRa Edge with this continuity, right? So, for example, if you have a high value asset that is manufactured on a factory, from the very beginning, you can track and trace that asset when you are indoor using Wi-Fi. Then you transition to the distribution stage, and then you go into the outdoor geolocation mode using GNSS, and so on, right? So this is a very interesting use case where you can cover both indoor and outdoor, right?
Hmm.
These are some metrics coming from real test comparing a LoRa Edge based device and a traditional GNSS tracker, right? And you can
Mhm.
see, right, the level of battery consumed after a couple of months, right, of simultaneous use, how the LoRa Edge tracker has basically consumed very little power,
Mm.
and the traditional tracker obviously is much more depleted, right? Important to mention here that obviously I mean, how long the device will last heavily depends on the frequency of
Mm.
scanning and transmission, obviously, right? But again, if since LoRa as a technology, as we were discussing at the beginning, is not aimed for real time, but rather sampling, every, let's say, mm, few minutes or hours or even days, it's a perfect combination with this approach to geolocation, right? Because uh, the sweet spot for LoRa somehow overlaps with the sweet spot for this approach to geolocation.
Mm. Hmm. Excellent.
Yeah, and then I guess we are ready to go into the AWS space, right? So
Yeah, so this can be paired then with AWS IoT Core, with the LoRaWAN. Yeah.
Yeah, absolutely. Yeah, and that's actually a feature that was announced in last reInvent in November, right? It was already in public preview since the LoRaWare Expo in Paris. I think it was July, and I'm really excited, right? So I want to first of all make it clear that AWS IoT Core device location is much more than just GNSS solving, right? It also includes other solvers such as Wi-Fi, or cellular-based geolocation or IP address geolocation, right, coming from different providers. In particular, we'll be discussing GNSS and to some extent Wi-Fi. The GNSS solver is provided by Semtech, so it's basically the Semtech cloud solver, which is now integrated natively in AWS, and specifically, as you mentioned, Dan, in companion to AWS IoT Core 401, the managed LMS
Yeah.
coming from Amazon,
Yeah,
right?
so this is kind of in a way, a triangulation of three technologies essentially, and so that's pretty cool.
Yeah, yeah, exactly. So let's say that you have, I don't know, you have a device such as this tracker, right? This is coming from one of our partners, Browan. It's also called the reference tracker, right? We also have other trackers coming from partners such as Miromiko, right?
Hmm.
It's a bit more industrial. You can see it has really a strong magnet, so you can attach to an industrial asset and then keep track of it, right? And we also have, let's say, a dev kit, in this case, also coming from Centec, right? Again, if you are more on the, let's say, builder mode, right? This is something
So
you can use.
let's give you a bigger view there. Yeah,
Yeah,
there we go.
exactly. This is the dev kit, right? And so basically, you will get any of these devices, and using a gateway, you can connect to AWS IoT Core Flora One, right? So then the actual benefit compared to, let's say, a previous topology for such a solution is that instead of having to write some code, it's not rocket science code, but obviously it's still some code in order to interface these devices and the payload coming from the LoRaWAN network server in order to invoke the cloud size solver. Now, AWS IoT Core for LoRaWAN will do it for you. It's basically a no-code solution, right? So
Mm-hmm.
we somehow, as let's say in the best AWS tradition, what we are doing here is removing all the undifferentiated heavy lifting, which is not different from use case to use case, and solving it for the customer, right? So now, and I think we will see in the console in a second, right? As soon as you configure a device in AWS IoT Core Follower One as a position-aware device, then automatically, whenever a nav message arrives from this LoRa Edge device, then the LNS will invoke the solver, right? Now branded as AWS IoT Core Follower One device location, and you will get the latitude and longitude, let's say, automatically, right? So then you can use
Mm.
it downstream for
That's
doing
pretty cool.
something like geofencing, right? And that's exactly what I think what
Yeah,
we are showcasing next, right?
Yeah.
yeah.
I
So you've got a demo for this. Oh, go ahead, Nanette.
No, nice. I immediately imagine the scale and the use cases where our customers will be having with this, because the main issue is always like, how do you make sure that this device is, as you said, like battery operated and the battery lasts. And from the cloud perspective, I just want to put this device on like a machine or something and just have it already done, not write any piece of code like that. So I can just imagine like how many people will jump on this if they haven't yet.
Yeah, absolutely. I think it's actually making it as you mentioned. I mean, reducing all the unnecessary complexity or
Yes.
creating this illusion of simplicity. As we saw in the technical slides, there is a non-neglectable complexity behind the solution, as with anything. I guess
Yes.
that is somehow useful, right? But then I guess the ability to create this simplicity, illusion of simplicity, is really what makes the difference, right? So probably
Exactly.
if you can bring the
Yeah,
slide,
yeah. Let's
then
take a look at
exactly. So
what this looks like. Yeah.
yeah, this is like an
Nice.
end-to-end solution, right? That basically leverage multiple components in the AWS ecosystem and uses a real tracker, right? We will see it's a real thing, right? I took my dog for a walk, I think yesterday, the day before, right, with one of these tracker, right, and then this tracker is connected to a gateway that is configured to send data to AWS IoT Core Floor One, And then once the data is on AWS platform, first things that happen is that because this device is configured in the LNS as a position aware device, it will automatically invoke device location, and I will get this nav message translated into latitude and longitude, right?
Yes.
Next step will be using the rules engine, send that information to mainly two destinations. First of all, the Amazon Location Service. Again, it's a kind of recent integration between IoT Core and Amazon Location Service, and I'm using it basically for two purposes, right? First, I will create a logical tracker that somehow represents the physical tracker, right? Some sort of digital twin, right? And then using this logical tracker, I can associate it to a geofence, or more strictly, a geofence collection, which basically defines what is the region where I'm allowed to use the tracker, right?
Hmm.
I will then handle the events being produced by Amazon Location Service, and specifically the geofence, in order to signal, let's say, over an SMS message through going through an SNS topic, whenever I enter or exit the geofence, right? So that's
Hmm.
the lower path in the diagram, right? And then if I want to have, let's say, deeper visibility, I can certainly again leverage the native integration between IoT core rules engine and a time series database such as TimeStream to store the data and then dashboard it using Grafana, right?
Right.
And that's
Because
basically what.
you can capture more data than just the location too, right? So that's the other thing is
Absolutely, yeah.
it's other dimensions beyond just the location.
Yeah, and that's very important. Like say I mean, obviously this is just a kind of demonstration, right? And that's why we are basically focusing on location. But this is a very good point, Dan. I mean, if you move, like say, into cattle tracking, then probably you are not, like say, fully served by just relying on location, but you want to have additional sensors, such as, for example, I don't know, understanding what is the position of the cow to detect whether or not it's moving, and figure out if it's healthy or not. We even have partners that has developed a solution for analyzing, let's say, the
Yeah.
digestion of the cow by having a bolus sensor that also use LoRa as communication channel. So yeah, absolutely. This is just, let's say, a starting point for really interesting use cases.
Yeah, I remember this solution. So, but this was specific to dogs, but it can be extended further. Is like there was a dog tracker that, based on the accelerometer data, can detect if the dog is healthy or not,
Mm.
in terms of like the walking patterns or whatever.
Oh, the way
So
it's
yeah,
moving. Oh yeah.
yeah,
Interesting.
really interesting stuff.
Yeah, absolutely. No, even just with location data, there are a bunch of things that you can infer, right? But
Yeah,
certainly, I mean, the most likely use cases will let's say, aggregate additional data. So probably let's take a quick walk over the
Yeah. Let's jump
how the
into this.
yeah, how the actual things looks like, right? So again, I'll try to keep it focused, as we don't really have much time. But I mean, everything starts, as mentioned, with the gateway configuration, right? So the gateway will use, let's say, TLS credentials in order to authenticate against the LNS, against AWS IoT Core 1. So that is the first step, right? You can see here what you do in the LNS is create these credentials and obtain also the endpoints that then you can push to your gateway. In this case, I'm using a Bro1 Mini Hub Pro, as I showed you before, right? And that basically means that as soon as this gateway is properly configured, any package that it will receive from any device in the within range, right, will be forwarded to the LNS, right? It's important to
Hmm.
mention that typically gateways don't really bring much intelligence, right? That's, let's say, the typical one, right? So that's the first configuration step. And then the next one is actually the end device configuration, right? So this tracker, you need to refer to a couple of profiles that we can quickly show what information is in this profile. But basically, it includes information about the regional band where the device operates, also include information about the specific revision of LoRa that the device is, let's say, compatible with, right? And complementing the device profile, you also have something called service profile, which is mainly about let's say, the rates, the uplink and downlink rates that the device will support, and also details such as whether or not you want to include metadata coming from the gateway into the payload, right? So once you have established these two, let's say, prerequisites, then you can onboard your device. And what is really, let's say, new, so you see these are the two profiles, right? Is that, let's say, the traditional or baseline AWS IoT Core for LoRaWAN configuration mode for a device will ask you as a end user to provide a destination, which is basically where you will push the data coming from that device, right? This is,
Mm.
let's say, the pre-device location configuration, right? As we were discussing, specifically when it comes to a LoRa Edge device, there is really not much that you can do with that raw data, right? Because this nav message is basically, again, some sort of, let's say, pre-cook information, right? So
Mm.
you need to go through the final step, right? And that's
Looks
where
like a hash or something like that.
uh,
Yeah.
it's
Mm.
actually, I guess, is what is called, I mean, just to keep it simple, what is somehow called pseudo ranges, right? So it's approximate
Mhm.
information coming
Mm.
from the space vehicle signer, right? But you need this post processing, right? Then what is new coming from device location is that now you just turn the switch on. You say this is a location aware device, and it will automatically invoke device location, basically the solver on your behalf, right?
And
You
so
need to
this is integrated right directly into the
absolutely,
console.
yeah, yeah,
You
yeah.
didn't add this or
No,
anything.
no,
This
no.
is right there.
Absolutely, absolutely. Yeah, this is let's say coming from the original AWS console. You need to specify the F port, which is some sort of, let's say, indication of what what is the application information that you're handling, right? Uh, and uh, and then finally, very important as well, you need to specify what is the destination for the already solved data. I mean, where you want to put the latitude and longitude,
Mhm.
in which channel, so to say, right?
Mm.
Going into more AWS IoT Core specific terms, that can be, I think, either a topic or, as I'm using today, an IoT rule, right? And that's all you need. So again, you see, there is really no code at all required to make this device having its position solved, right? When using this native integration with IoT Core, right? So what is next is basically, as we discussed, what you do with the data, right? And as we discussed, there are two destinations, basically two rules. The first one is the raw data. The second one is the already uh, resolved position data, right? So for the first rule, actually, I'm doing very little. I think I'm just pushing it to CloudWatch logs, right? And we'll see
Mhm.
why in a second. So if I inspect the CloudWatch log for this rule, you will see, right? These are all the message that has been received in the last 2-3 days, right? And you see that you have a bunch of details coming from the gateway, such as, for example, what is the spreading factor that has been used, as we were discussing before. We are using spreading factor 8. What is the bandwidth? Whether or not the network is controlling the spreading factor is what is called adaptive data rate. I mean, there are a bunch of details, right? But when it comes to the actual data payload, right, there is little you can do with it, right? I mean, it's
Mm.
base 64 encoded, as you can see.
Mhm.
But even if you decode it, again, you will, assuming that this is a specific message corresponds to enough message, right? You will see something that you cannot really uh, translate into useful
Mhm.
information, right? So that's why I'm just, let's say, pushing it to CloudWatch logs, right? And then the second action, right? The one that actually, sorry, the second rule, the one that actually deals with the already solved position, that's where
Translating.
the really interesting stuff is happening, right? So I'm
Mm.
also pushing to CloudWatch logs, and we'll see in a second, again for troubleshooting purpose. But as we saw in the architectural diagram before, I'm also pushing it to both Amazon Location Service and time stream table, right? So I can have three outcomes: ability to really inspect the payloads and understand what is the format, ability to uh, connected with Amazon Location Service for geofencing, right? And finally, ability to store in time stream in order to dashboard using Grafana.
Yeah.
Okay. So yeah, very quickly, the CloudWatch logs for now the solve position. As you can see now, it really contains data that you can really let's say properly understand,
Yeah.
right? First of all,
Oh,
you have
right.
the
Yeah, that's
position.
it.
Yeah,
Oh, yeah,
exactly.
go ahead.
You have the coordinates, right? Well, let me make it a bit larger. You have the coordinates, right? And you also have additional information, metadata information,
Mm.
but also, and this is something specifically for the GNSS solver, you will get information about the accuracy, right? So going back to your question, Nenad, in this example, and obviously it heavily depends on what are the sky view conditions, right? We
Yeah.
managed to get a position solved with an accuracy of 18 meters, right? Which is again
That's pretty
likely
good.
good enough for most of the use cases,
Yeah.
right?
Yeah. Mm.
You can see as well probably here some Wi-Fi uh, positions. I know it's a Wi-Fi because it contains node altitude, right? So
Hmm,
again,
Mm.
interesting.
the same tracker is able to gather both Wi-Fi data points and GNSS data points depending on the sky view conditions, right?
And I'm curious, what's the accuracy there with the Wi-Fi?
Well, you need to add it to your wish list, right? Yeah, unfortunately, the solver being used for Wi-Fi does not include accuracy
I
information.
see.
That's
Yeah.
yeah, it's a good opportunity for a product feature request, I guess.
Yeah, that would be interesting to see as well.
Absolutely. Yeah, what I can tell you, I mean, generally speaking, not specific about device location, is that certainly Wi-Fi geolocation accuracy heavily depends on the, I mean, obviously on the quality of the database that you're using for
Yeah.
that, but certainly as well of the density of access point, right? I mean, if you are, for example, I'm in a urban region,
Of course.
we'll see next that is really quite easy to get a bunch of access point within reach, right?
Yeah.
Uh, typically in this case can be very accurate, right? I guess, I mean, I don't want to be very bold on that, but I guess it's reasonable to get accuracies in the order of 10, 20 meters
Mm,
using
makes
Wi-Fi.
sense. Makes sense. That's pretty good, actually.
Yeah.
Yeah.
And then yeah, let's go a bit deeper. So this is basically what you get, right? So you get the
Hmm.
coordinates, you can get accuracy as well in some cases, right? And that's exactly what we need in order to, going back to the rule, right? In order to really configure the two next actions, right? So first of all, let's take a look into the location action, right? So here, as you can see, I'm basically, first of all, associating it with the Amazon Location Service logical tracker, right? As I mentioned before. And then I'm using substitution templates to extract some details or some attributes from the payload, right? Mainly the device ID, longitude and latitude, and also I'm producing timestamp, right? Uh,
Nice.
what happened next is that if you go to device location, sorry, if you go to Amazon Location Service, right, you will have your logical tracker configured here,
Mm.
and this tracker can be linked to a geofence collection. So if I
Hmm.
click here, this is, as the names imply, a collection of geometries, right? Unfortunately, I don't know if this can be visualized in Amazon Location Service console, but I can tell you that this geofence looks like this, right? So this is the GeoJSON document that models this geometry, right? And this is basically some irregular shape around my home, right? So I took my dog for a walk. I went to this square and then back, right? And we will see next how these points looks like and what were the events that were received back and forth, right? So again, using this native integration between IoT Core Rules Engine and Amazon Location Service, you get it again without really writing a single line of code, right?
That's
And then
pretty good.
before we see the actual dashboard, the final integration is with the time stream
Hmm.
database, and it's very similar, right? I just extract 4 dimensions, right? It contains the ID of the device. This is the FUI in the LoRaWAN space. Then longitude, latitude, and the accuracy, right? And yeah, and then finally, using Grafana, you can start dashboarding, right? So if I go to my Grafana dashboard here, you will see basically my work. So I have color code the points based on the source, right?
Hmm.
So the red points are Wi-Fi, right? You see that there is no accuracy there, and then the blue points are GNSS, right? So if I go over here, this is a bit worse, 95 meter. This is also a bit worse, 72 meter, right? This is just a subset of the
Yeah.
points, right? But you can tell. I mean, also if you analyze the timestamps, that let's say when I transition from here to here, then I receive an SMS from the Amazon location service through
Mm.
Event Bridge, notifying that my asset has exited the geofence, right? And then when I
Hmm.
return back from my walk, I got the complimentary message stating that my tracker, my logical tracker that is connected to my physical tracker, has entered the geofence, right? So it's really, really, like say, easy to set up, and yeah, and the beauty is that it's zero line of code, strictly speaking.
It's pretty cool.
Yeah, just some JSON manipulation and some
Absolutely,
rules
absolutely.
uh,
It's pretty
definition in
cool.
the rules engine and so forth.
Yeah,
That is
that's really cool.
fantastic.
Yeah. Yeah, again,
Yeah.
it's just a starting point. I mean, I'm pretty sure that our customers will really get the building blocks, right? Get these trackers coming from Browan, coming from Miromico. Actually, I want to mention that we expect a significant number of tracker manufacturers bringing LoRa edge-based trackers in the next few months.
Mm,
Folks like Tectelic or Microtics or Seed, right? They're all working on LoRa Edge-based trackers, right? That should be able to easily integrate with AWS IoT Core device location, and ultimately enable solution providers and end customers to start building location-aware solutions, right? Which is the final goal.
yeah.
Yes.
So, how to get started? I think
Yeah.
that I would love to try this out myself and
Yeah.
Yeah,
do
absolutely.
some geofencing around San Francisco, just like
Yeah.
you've
I,
done
I
here
was
in
just
Madrid.
mentioning. I was just mentioning. I want to buy this for my kids. So some geofencing. Where can
Yeah,
I get
yeah, yeah.
it?
Be ready, Nenad, right? You might learn things that you would prefer not knowing,
Yeah.
right? Just kidding. Okay, yeah, no, that's a good point. Then, so yeah, my suggestion will be to use a SaaS application coming from Semtech, LoRa Cloud Locator, right? It's free to use. It's a very simple web application. Its main intent is actually help our prospects and customer evaluate the underlying technology. So rather than just presenting all these uh, slides, right? We prefer to really enable them to try the technology, right? So just need to visit loracloudlocator.com, right? And then the first thing that you need to basically decide is which tracker you will use for your evaluation, right?
Mhm.
We include a list of trackers coming both from Semtech, right, as you see here, and also from our partners, Digital Matter, Miromico, and we even have a traditional tracker coming from Browan, right, just for comparison purpose, right. You can order this directly from this page, right, and you can get your tracker coming from CalChip or Indesma Tech based on your region,
Yes.
right. The next decision point is which network you will use, right? So we support both public network, right, which is probably a bit simpler because you don't need to acquire a gateway or configure it, right? In that front, we support EveryNet, we support Helium, Orange, Senet, Swisscom, and the Things network, right, which is also quite popular, right? So if you are within the area of coverage of any of these public network operators, then all you need to do is go for your tracker and start using Locator, right?
Mm,
If on the other hand, you are not under the area of coverage, or you prefer to experiment with your own private network, as we discussed before, we are relying on AWS IoT Core 401 for that, right? So you can order a compatible gateway and configure it. Again, using Locator it will be a matter of minutes, right? And that's all you need, right? So once you're ready, you can log in into Locator, and it will just take you a few minutes, right, to really get your tracker up and running and start seeing dots on the map, right? So uh,
that's cool. And
yeah,
and just to be clear, the trackers that you've got at Semtech, they're really reference designs,
that's
and ultimately this is for maybe a scalable solution that others would
yeah,
manufacture.
that's a very good point. Yeah, we basically aim both the reference tracker and also Locator as a tool, as a way to illustrate our partners. I mean, Semtech is not in the business of building end devices, right?
Hmm.
We actually work with partners such as
Mm.
Miromico, Microtic, C, Tectelic, right, to help them build devices, production grade devices based on this reference design, right?
Yeah,
But yeah, basically you can get your tracker ad in a matter of minutes. You can select any of the supported tracker types, right? Let's call it AWS IoT builders, right? Then you select your tracker type. For example, let's assume that I'm using a reference design here.
Hmm.
And yeah, you can easily just enter your PIN code, select the network, any of the networks that we mentioned before, including IoT Core Floor 1, and then you click on create, and you will start seeing data. Again, it should be a matter of minutes, right? Let me just quickly show what it looks like. And it's important to mention, as I told before, right, that this is not aimed for a real use case, right? So what we are
Yeah.
trying to do here is basically just improve or reduce the effort required to for a prospect to actually evaluate the underlying technology, right? So
Hmm.
once they are
Makes sense.
comfortable with the accuracy that they are observing, right? Once they are comfortable with the level of coverage in the region, once they are comfortable with the battery consumption pattern that they're observing, then they move from the evaluation phase, right, into the actual building phase, and that's where I will strongly suggest going into AWS IoT Core Floor 1 and IoT Core device location for the actual implementation of the solution that will be probably similar, at least the initial iterations, to the demo that we just showed, right? So that would be my suggestion. So again, locator.loracloud.com is free to try. All you need to do is order a tracker and start really experiencing the technology.
That's awesome. Yeah, I pasted the URL in the comments there, so feel free to click that and get started. Anything else to share here, Pedro?
Well, not really. Again, thanks again. I'm really, really happy to be back discussing about the AWS technology, right? And yeah, more than happy. I mean, if there's any follow-up question or opportunity where we can help, yeah, my responsibility in Semtech is actually helping our prospects and customers to properly use the technology, right? You name it LoRa, you name it LoRa Edge, right? So more than happy to see this ecosystem growing and more solutions and more devices being added.
Awesome. Well, thanks a lot for your time today, joining us. It's been educational, informative, just actually really cool to see a demo and the technology here is really neat, and that it's integrated with AWS IoT Core for LoRaWAN is just fantastic. So again, thanks a lot for taking the time. Again, Pedro Mendoza from Centec. So. Yeah, been a great session. Thanks so much. Ninad, anything else to share?
No, yeah, I really enjoy this. Going through that demo and explaining that in details. Kind of interesting technologies what you mentioned there. So pretty cool stuff.
All
Thanks a
right.
lot, Dan. And as mentioned, I'm really, really glad to be here, and I want to congratulate you for the excellent work you're doing, both of you and Alina and Saeed and Risha, right, around the let's say advocacy of IoT topics. So well done.
Oh, thank
Well,
you.
thank you. Thank you so much. Yeah, appreciate that. Well, let's see. We will be back next week, and so stay tuned for our live stream same time next week. And until then, so long.
Bye, everybody.